Hello everyone. This is my presentation for managing machine learning projects. So we'll be speaking on these 5 topics as part of this presentation. So the problem statement or the opportunity that I have selected is the forecast, the demand of vegetables for farmers in a specific region to grow the optimal number and right combination of vegetables that can increase revenue and reduce crop wastage. So yes, this problem exists among farmers in India where we do not have a definite method to predict demand, and the estimation is mostly based on observation and experience from past. And also they do not have a model that can predict accurately. So ML can make it feasible to solve the problem. Historical data will have to be collected from the farmers and live sales data will have to be recorded to refine the model. And this prediction of demand will help the farmers increase their revenue and reduce the wastage on farm. And these two things will eventually help them get the right price if the vegetables are available as per demand. Now, if we look at the CRISP DM business understanding and look at the problem success and factors, the target user for this problem statement could be the farmers as well as the online grocery sellers who source directly from the farmers. So basically we want to forecast the demand in advance so that the vegetable harvest is ready on time. As I mentioned before that uh, the current state is such that it is mostly based on observation and experience from past, and if demand is not identified correctly, the vegetables will go waste and farmers may not know what is the exact demand in the market. So we are establishing success by increased revenue and minimize crop wastage parameters. The metrics would be the reduction of average weight of uh, crop wastage, and the output will be the mean squared error of the demand forecast. The constraints here could be the forecast should be available well in advance for the crop cycle to reach the harvest stage at the time of demand. The factors in this problem statement are seasonality, the vegetables that are grown in a specific season, then there's weather, then there is what are the number of farmers in the area serving the demand, number of customers in the area, what is the situation of the cold storage available. Now to validate our solution, we will have to develop a hypothesis and testing with the users. So what we want to look at as hypothesis is that this demand forecasting will reduce crop wastage and it will increase farmers' revenue. So we'll go through multiple iterations to validate our solution. We'll create a mock-up solution first. We'll just choose say 3 vegetables grown by a farmer and collect historical data on these 3 vegetables and create a mocked-up model. We will use first a heuristic method to predict the demand. We'll take the average demand for these 3 vegetables chosen. Then we'll try to create a simple ML model and predict demand and also compare it with the heuristic prediction to set the benchmark. And then we'll further build on the CRISP TM steps to further refine the model to add more relevant features and more crop vegetables grown by the farmer. So in this ML system design, I think that the cloud ML will be more effective for demand forecasting as for the data storage there is no privacy related issue and we do not need immediate results for this, so latency is not an issue. A week's data can be collected and then the model can be retrained on a weekly schedule, and thus offline learning can be implemented for this ML model. We can make weekly predictions on a set of data and immediate predictions are not required. In this case, planning is required for crop production and therefore a batch prediction is most suitable for this. So looking at the potential risks in production, I see that training, serving, skew, and data drift could be the possible model issues. Training, serving, skew may occur if the model is trained on a data set which is just created based on interviews, and it might not include all the possible edge scenarios. And data drift is possible as the data that we have may not capture the abrupt weather changes or the shift in seasonality as a result of which the demand will not be inaccurately predicted. So this summarizes the entire ML problem statement and solution that I have for this presentation. Thank you very much.